In this mini lecture, we are going to be dealing with expanding upon packages and looking at the idea of generic packages and child packages. So one thing that you're probably asking is, well, a package is a great idea. We can store lots of information together, and we can keep everything the way we want it to, but the problem is what happens if you want to store more than one type of information or use a package for more than one type of information? You typically would have to create two different packages unless you use the generic package feature. Now the first thing you may be asking, well, what's a limited private? Because type here. Now what I didn't cover in the previous video, and I am covering in this one, is we can allow procedures in the quote-unquote main body of the program to create a stack type and to store a stack type. However, if we make it private, that means that the only functions and procedures that can access the particular stack type would be in the particular package body for this file. In other words, it's not accessible outside of it. So what this basically means is it makes the stack private in the sense that you can store one in your own program, but you can't access any of the information inside of it for assignment statements or for output. So in this case, we have a package that says, well, there's a stack type. If you want to keep a stack in your program, that's fine, but if you want to do anything with it, you got to talk to me about it. So we have an exception or exceptions that are created for telling it's full or it's empty. And then if it's empty, we have a function that returns true or for empty or full. And we have a procedure that allows us to push a piece of information onto the stack, and a pop that allows us to remove an item from the stack, and the top will return an integer that is on the top of the stack. So this is a stack that deals with integer variables, or storing integer variables, and we are using an array for this, and a stack type essentially contains an element array, which is an array of integers, and then we have an index into what the top of the stack is. And then you can imagine the push, the pop, and the top are all working for this. Are we using this particular data type for this? So essentially, when we're wanting to reuse this, well, we'd have to go through and I'd have to change my integers in all of these different places to whatever type I wanted. Now, what generic packages allow us to do is we have the idea of quote-unquote formal parameters. And these just simply say, this is what this is going to be. And our actual parameters are going to be found in the client. So essentially we're distancing ourselves from saying this is type integer. We're going to have a formal parameter say this is the stack variable type, and then the actual stack variable type would be provided by the client. So here's what this would look like in a generic sense. So before our package in our specification, we would create a generic section that would say that the size is positive, and we would have an item type that would be generic. Now inside of the package, well, we're going to have our stack, much the same as we had before, and except in this case, whenever we're pushing something, we're pushing an item type, not an integer. And whenever we're returning something, we're returning an item type. And everything is now using item types. Now, the particular body of the main procedure that we would use this, well, obviously we'd have our with stack package that say, okay, we'd have an averages, and then to instantiate, in other words, to create one of these packages we want to use, instead of just saying, well, variable colon variable type, now we have to create a integers package that is a new stack package, which is what we just looked at, that holds 1,000 integer, or basically 1,000 variables of type integer. Because if we look back, we have the size and the item type. And the private portion of this essentially means that you aren't able to access and use those variables outside of the stack package. And then once we have created the packages, then we can go through and use that particular package, and then we can declare an integer stack of this integer stack package.stack, because I have to specify, well, here's the specialized version of the generic package, and then I can actually go through and pass this to the procedures inside of the package body. And we can go through and just use this just the same as we always have before. Now if you notice, in this case, I'm using the particular type and the push for this. And this is because the push procedure itself is generic, and we have to specify to the specific procedure that is referred to in the int stack package that we declared in the previous slide. Now, packages are not the only thing that can be generic. We can also have generic procedures. Now, what a generic procedure allows is the ability to essentially have a type just by itself, or a procedure that's passed in, have this type be generic. So in other words, this is a generic swap, and then obviously this would go in the specification file, this would go in the implementation, and then in the client I would say, well, I'm going to have a swap integer procedure that is a generic swap, except the item type is going to be integer, and then I could call this and it would swap them. So if you ever wondered how you could write a procedure that would work for swapping integers or swapping doubles or floats, or my favorite type here that you created as your own type, you could do that. So we have generic packages and we have generic procedures. Typically, we mostly worry about generic packages. However, if there's a small instance where you don't need a full-blown package, so to speak, and you just need a certain procedure, it is fully acceptable to do that this way. Now, I'm going to bring up the previous slides and we will briefly look at what a child package is. Now, one problem with, let's find the right slide. Looks like I didn't even bring those up anyway. One second, here we are, child packages. Sorry for the delay. So essentially what a child package does is, what happens if you're going along, you're using somebody else's package, it's got lots of great variables, it's got lots of great procedures and functions, has almost everything you need, but it's got two things that are missing. Now, if you don't have access to the actual source for this, in other words, they gave you, say, a .o file and just say, hey, link this into your program and you'll get all this great information, and gave you the specification for it, they could do that. Now, the problem is what would, if you need to add some information to this, like a couple extra procedures that would use the types in that, well, unless you got the source code, you're up the creek without a paddle. Except in Ada, we have the idea of a child package. And it essentially allows you to use the types and the procedures in the parent package in the child package. And the child package can add new functions or procedures and types. It's sort of similar to inheritance. And we refer to this as parent.child. So in other words, in Ada, we can think of this as ada.textio. So there's an Ada package, and then the text.io is a child package for that. And it's very simple to do. We essentially name it as parent-child.ads and parent-child.asp. So this adds in the ability to add in some extra procedures and functions, and you just would simply say, when you're using it, what you would do is you just say with parent.child, use parent.child, and it will go through and look in these particular files for that information. So if you've created a package and then need to add some information to the package, you could do so. So if we think back to our points package, well, the points could be the parent and lines could be the child, so this would be points-line, and the line would use the points and then add in the type, line, and procedures and functions that would work on lines themselves. Now that may or may not be a good idea, but that's just one particular example of how this feature could be implemented. So what we've covered is taking packages and moving away from just simple one type only packages and moving into generic packages and thinking about how can we take this information and make it generic so that we're able to pass it around and use the functionality multiple times. It's like templates in other languages.